Hi, everyone. Thank you for joining us today. My name is Brock Sorensen. I'm a customer success manager here at Prolific, and I'll be your host for today's webinar. I'm joined by my esteemed guest, Tom Hosking, and the topic of today's discussion is a research paper that Tom wrote earlier this year regarding human feedback and the role that it plays within large language model training. Tom is a final year PhD student in the informatics department at the University of Edinburgh, advised by Mirella Lapata. His primary research interest focuses on natural language generation, including improving the structure of representations or data structures within models and developing methods for automatic and human evaluation of system outputs. Before starting his PhD, Tom spent time working on natural language processing at multiple startups and also worked as a quant trader in the past. He also worked as a research intern at Cohere, which is where he completed this research. Tom, thank you so much for joining me today. I'm sure there are things that I missed in that brief introduction, so I'll hand it off to you to say hello and fill any gaps before we jump in.
Yeah, hi everyone. Thanks so much for inviting me on. This was a really fun project to work on, and it was great to kind of work with Cohere a little bit on it as well. So yeah, looking forward to chatting about what we did and what we found, and yeah, I guess at a really high level, the kind of goal of this paper was really to start a conversation about some of these topics. So yeah, the more we can get people talking about this stuff, the better, I think.
Great. Thanks, Tom. Yeah, I'm keen to dive in and discuss the research and the paper itself. As mentioned, the main topic is human feedback, and you posit that while widely considered the standard for evaluating LLM output in the past, there may be some biases and flaws built into this feedback loop that should be considered. Do you care to elaborate more on the general themes and sort of the topic of the paper?
Yeah, sure. So large language models, as I'm sure you and everyone watching this knows, have just absolutely exploded in the last few years. They're impressive. They can seem to do all this stuff. And we've kind of gone from a world where NLP models are designed for specific tasks, and that makes them quite comparatively easy to evaluate because you know what task you're trying to achieve. So we've gone from that paradigm to a world where we have these models. They're incredibly flexible. They're incredibly adaptable. And they can kind of do stuff that they weren't explicitly trained to do during their kind of training period. This is so far so good. The problem with this is then, how do we know how good they are at this stuff? If we don't know what we want to do with them, how can we measure how good they are at it? So far, essentially the standard that's kind of emerged is to use human feedback or human preference scores. So the idea is you get some output from this model, you show it to people, and you say, how good do you think this is? This seems pretty sensible. We want people to like these models. We want them to use them. So asking them, how good is it, seems pretty reasonable, right? The issue here is that no one's quite checked whether this works and whether these preference scores and this way of measuring model performance, whether it's biased, whether it's accurate, whether it's reliable. So that was really the starting point for the study, is to kind of say, we've hit this sort of de facto standard way of doing it. Everyone's doing it. We should probably check that it's the right thing to do and that we're not accidentally making a mistake. So that's where the initial research question kind of came from.
Interesting. Yeah, and I was curious, like, what inspired you to take your research in this direction? I'm sure it's maybe just questions that have popped into your head as you've been performing other research, sort of thinking, is this the right way of doing things? Is that accurate?
Yeah, kind of. I guess so. I think I'm naturally quite a skeptical person. It's taken me honestly, it's taken me a little while to get on board the kind of LLM train. So I've kind of seen all these, seen the kind of hype around it and the popularity that these models have seen, and the skeptic in me has kind of gone, it seems like if you sort of look at all the demos and you look at all the posts on Twitter, like, NLP is solved, and that almost certainly isn't true. But I guess more concretely, what are these models performing as well as we think they are. And yeah, designing a kind of slightly critical approach to that, and checking how good these models are is kind of where we're coming from.
Yeah, definitely. Can you tell me a little bit about the study itself and the design and the structure?
Yeah, sure. So there are two main parts. So bear with me, and I'll kind of try and run through them both. The second one does lead from the first, so hopefully it will make sense. So the starting point really was the main way that human feedback is gathered, or human preferences, or use them kind of interchangeably. Like I said, you show people model outputs, and then you ask them essentially for a rating, and you say, "Here's some output. Please rate it from 1 to 5." And there might be some instructions that come alongside that. Maybe please check whether it's harmful. Please check whether it's fluent. This kind of thing. But you essentially get one score, and that's it. So one of the original motivations was, well, wouldn't it be nice to have multiple scores? If we're trying to work out, if we're a model developer such as Cohere, and we build a kind of fancy new version, and we say, great, have we done a good job? Is this a better model? It would be nice to know, maybe yes, it's a better model, but it's kind of even more fluent than the old version, but actually we've taken a little hit in, let's say, safety. Knowing those kind of trade-offs would seem like a really important thing to deal with. If you end up in that situation where the model overall is better, but it's taken a bit of a hit in safety, you maybe don't want to ship that model. That's going to cause you some problems down the line. So the first study that we designed was, we wanted to take these overall preference scores, these overall 1 to 5 ratings, and try to work out what factors were covered and which factors were not covered. So what we did is we took a bunch of LLMs, we took a bunch of tasks. So there's a summarization task, a product description task, so where you feed the model like a product name and specification about the product, and you say, please generate me a compelling description for this product. And so we took these outputs, and then we showed them to 2 groups of annotators, or 2 groups of participants. Again, I'll use the 2 interchangeably. The first group, we said, please give us ratings 1 to 5. Minimal instructions, just please, use whatever factors you think are important. Let us know how good this output is. Then the second group, we came up with 10 error types. These are errors that they're sort of minimum properties. So they're errors that these models should never make. Things like safety, fluency, incorrect refusal, this kind of thing, factuality as well. And we asked the second group of annotators to check whether the outputs contained each of these errors. So once we've done this, we now have a set of ratings for each output, and we have a set of error labels for each output. So these error labels are, does the output contain the error or not contain the error? Once we have these kind of 2 parallel data sets, what we did is trained a regression model to try and predict the ratings from the error types. Why did we do this? So we can then inspect the loadings or the weightings of the regression model to look at how important each of the error types is in its contribution to the overall rating. What we found is that the error that had the highest weighting was refusal. So this is incorrect refusal. Basically, if you ask the model, please tell me how to bake a cake, and it says, I'm sorry, I'm a helpful harmless language model, I can't help with that. Super annoying. And sure enough, that had the biggest contribution. Formatting, relevance, these had a pretty high score, but kind of problematically, inconsistency and factuality had quite low scores. And this is kind of a problem. I think we'd probably all agree that we want these models to be factual. We don't want them to just outright lie. And it seems like if we're using these aggregated high-level preference scores to measure how models perform, we're essentially underrepresenting how factual they are, and this isn't a good thing. So in a sense, it's kind of reassuring because it's not zero, right? The weighting is positive, but it's significantly less than all the other ones. So this is bad. So this was experiment one, and as part of that experiment, so we also we included some kind of safety checks. So people who've worked in annotation before will probably have included these things. They're sometimes called attention checks. You're basically checking whether your annotators are doing the task that you've asked them to do, and getting an estimate of data quality. And one of the setups that we used was we included, so the original experimental setup was we showed people pairs of outputs and we asked them to rate each of them. Now, for some of these pairs, what we did was we made the output be from the same model, but one of the pair was from a different input. So this sounds like a really weird thing to do, but it's basically a kind of a controlled example where you know that the model is the same, but one is based on the wrong input and therefore should absolutely be worse than the one that was based on the right input. So you can kind of check, are annotators correctly ordering these? But we did this for the error types as well. And what should happen in this situation is the error types that are essentially independent of the input, so things like formatting or safety, these are pretty, if the model is disfluent, it's disfluent regardless of what the input is. So these should be independent of the original input. But some of the other ones, things like relevance or inconsistency, are heavily input dependent, and we should see that these are penalized for the this kind of control example. Now, that was a long build up, but I'll come to the results. So what we found is that annotators correctly didn't penalize formatting, refusal, safety, these kinds of things. And they did correctly penalize relevance and inconsistency. So it looks like the annotators are doing the right thing, but they somewhat penalized factuality. Now, this is a little bit weird. We asked them to evaluate the factuality of the outputs in absolute terms. So regardless of what the input says, is this true? And the fact that showing them an output from a different input and them saying this isn't factual implies that they're kind of struggling to do this. I recognize it's quite a subtle thing to ask participants to do, but it kind of raised a little red flag for us. We were kind of, hold on, if they're finding this confusing or this is kind of biasing their ratings, what else is going on? Are there other biasing factors? Does that make sense? Make sense so far?
Yeah, definitely.
Cool. So this leads us to experiment 2. And what we wanted to do was say, well, okay, so we know that the annotators are struggling to do this. They're struggling to annotate for factuality. What other biasing factors might be going on? And we kind of sat around a little bit and kind of thought about it. And we figured that it maybe how assertive the model is might bias people. I think this is probably true in people as well. If you have someone who kind of confidently tells you something, you're more likely to believe them. If they say, "Yep, it's this," you go, "Okay, sure." Whereas if they go, "Well, maybe it's this, but there's some kind of disagreement," then you're probably more likely to go away and check because they've told you that there's some potential disagreement. So we thought that assertiveness maybe was going to have an effect. I guess sort of similarly, we thought that maybe the complexity of the output might have some kind of biasing effect. So if you have output that uses a lot of jargon or uses complicated words, then maybe people would perceive that as coming from an expert rather than something that kind of uses very simple, almost kind of childish language. You'd go, well, you don't know what you're talking about. So these were our hypotheses. Do the assertiveness and the complexity of output bias judgments about factuality in language model outputs, and indeed all the other error types as well. Now, the cool thing about instruction-tuned language models is you can tell them what to do. So you can say, please be more assertive, or please write in a really complex way, use lots of jargon. So this is what we did. We said, we essentially ran the same experiment as before, but this time we asked the model to be more assertive and less assertive, and to be more complex and less complex. Regenerated all the outputs, and then essentially just ran exactly the same setup again. We asked for overall ratings, and we asked for error annotations. Alongside this, so it's possible that when you ask the model be more complex or use lots of jargon, it's possible that this actually genuinely makes the model better. If you say kind of pretend to be an expert, then maybe the model, we don't really know how these models work inside. Maybe it goes, oh, okay, I'll switch into expert mode and produce something that is genuinely actually better. So to account for that, we annotated, I think, 300 of these outputs ourselves to act as a kind of expert annotation. So this isn't perfect. Am I an expert in all this stuff? We can debate that. But I think what is true is I was invested in the outcome of the study. Like, I wanted this to succeed. I set myself plenty of time to do this. And basically, no matter how long it took me to check each of these outputs, I just did it. So in that sense, I was kind of an expert. So this is our experimental setup. We have more assertive outputs and less assertive outputs. We have more complex outputs and less complex outputs. Then we're going to get annotators to check them for errors, and I'm also going to check a bunch of errors. What we found is that, so if you look at the difference in detected error rates between annotators and experts, you find that annotators are less likely to identify factuality errors in the more assertive outputs. So this kind of validates our original hypothesis that more assertive outputs are basically less likely to get fact-checked. People trust them more. And again, this should be concerning. If we're going to go and do human annotation of language model outputs and check them for factuality and check them for other error types, then it seems like the assertiveness of that output is a pretty big confounding factor. And maybe we're not, maybe we are measuring factuality to some degree, but we're also essentially measuring how assertive it is. So if we're using this for evaluation, that's already not great. If we're using it for evaluation with a view to, say, model selection, maybe we have some kind of candidate models and we go and get them annotated and get them scored, and we say, okay, we'll pick the most factual one, then we're also picking potentially the most assertive one. What we're seeing increasingly is it's becoming more common for people to not just evaluate models with this human feedback, but also to train on it. And if we start doing that, then we've really created a feedback loop where we're actually telling the model, we think we're telling the model to be better, or we think we're telling it to be more factual, but actually we're telling it also to be more assertive. So this is really a kind of giant red flag to me, and raises, I think, real questions about how we move forward and how we evaluate models in the future.
Yeah, and you sort of hinted at this towards the end there, but I guess like long-lasting implications, like what do you see from those results where we're training these models to be confident and assertive regardless of whether they're right or wrong?
Yeah, so we kind of ran out of time to do a really targeted study on this, but there's an additional analysis in the paper we used a kind of range of models as part of the experiment. Some of these were trained using human feedback, or were trained on human feedback rather. Some of them were not. And what we found, it's probably my favorite plot in the paper. If you plot the perceived quality according to annotators against the perceived assertiveness according to annotators, you find that the two are correlated. So this kind of makes sense. Like people prefer more assertive output. I guess at the extreme, it may be quite annoying if the model is sort of hedging all the time and they're saying, "Oh, I don't really know." Like, come on, tell me the answer. So this, at a high level, this makes sense. But if you dig down into this plot a little deeper, what you find is that there's a systematic variation by the models, by model rather. So if you kind of normalize by quality, you find that some of the models have a lower assertiveness than others, and I think this is really interesting. So it turns out that the ones that have a higher assertiveness for the same quality level are the ones that were trained on human feedback scores. So it's not super tight evidence, because there's lots of things going on. That the training data is different, the model architecture is different, they're different sizes. It would be really great to have a kind of much more targeted experiment to check this. But I think this is starting to indicate it raises the suspicion, certainly, that maybe training on these human feedback scores is kind of disproportionately exacerbating this problem with assertiveness. So I kind of like to think of it, if you imagine that training on human feedback gets you like a +1 in quality, it seems like maybe it's accidentally getting you a +2 in assertiveness. And this doesn't seem like a good thing. I would argue that having a model that is it's sort of correct but underconfident is much better than having one that is overconfident and wrong. So I think this is it's kind of early days, and I'd love to see more work on this. But yeah, I think this raises some kind of problematic questions about training on human feedback.
Yeah, definitely. And it seems like the biggest, I guess the missing piece, right, is this error criteria, specifically factuality. Like how would you propose maybe addressing that issue and making sure that factuality is sort of a core component to what is being presented in these outputs?
Yeah, so I've had a whole bunch of people ask me this. The paper's quite it's a little bit of a downer, I guess. We raise all these issues and then go, and that's it. I think so. We didn't test any mitigation strategies, so I can only kind of speculate. But I think there are two broad directions. So the first is, if we know that annotators are biased by assertiveness, and we know that overall preference scores are underrepresenting factuality, then maybe we can train our annotators or train our participants to try and account for this. So if we give them good instructions, give them plenty of examples of what exactly it is we're looking for, what precisely do we mean by factual or not factual? What's the difference between that and the other factors? Include kind of warnings saying, don't be swayed by the assertiveness just because it's confident. Check it anyway. Other things like, again, these are kind of, in many ways, these are old problems. These have been issues that have been around since we've been doing human evaluation. But let's be honest, annotators, participants are not the best paid people. It's hardly, they're not necessarily on board with the project. They're not invested in the outcome. And that's not their fault. It's just the kind of setup, I guess. Realizing that and engaging with it, and potentially curating a trained, invested, better paid set of annotators who have some skin in the game, and in helping them, what's the way of putting this? Enabling them to do the right thing, I guess. And if they come across an example where checking it actually takes a whole bunch of time, then compensate them for that time. I think the standard setup at the moment is to kind of just hope for it and to just kind of get volume through, and that incentivizes annotators to do volume rather than quality. So this is one direction. I'm a little skeptical about it. I think that there's a kind of a tricky trade-off. Like at the more instruction you give annotators, the more confusing it is. I had a really interesting conversation at the conference that we presented this work at with somebody who works in human annotation for one of the big companies that everyone will have definitely heard of. And essentially they said that their annotation guidelines are now 15 pages long, and it takes a month to onboard a new annotator. Now, maybe that works. Maybe it doesn't, but that is a huge increase in annotation cost and time and effort for something that, as far as I could tell, is not super validated. So it's kind of like playing whack-a-mole. Like each time you find okay, so we go, okay, assertiveness is a problem. All right, we'll patch that. And then it turns out there's a great paper from Anthropic that shows very similar results to ours, but for sycophancy. So this is where the model is kind of sucks up to you and is trying to be super nice. So we go, okay, we've hit assertiveness. Great, we'll hit sycophancy. I didn't really go into detail about complexity. It's not as big an effect, but we go, okay, we'll hit complexity. And we go, great, are we done? Almost certainly not. There's going to be other factors out there that have some kind of biasing effect. We just haven't found them yet. So this approach of training annotators and kind of trying to plug the gaps, I think it will help, but it's never going to be perfect. You're always going to be chasing around trying to find the stuff you've missed, and you will always miss stuff, almost by definition. So that's direction one. Direction two, I think, is much more difficult, but also much more interesting. And if we come back to what I was saying towards the beginning, where let's step back. What are we trying to do? We're trying to build models that are useful for people. You can kind of argue about exactly what that means, but at a high level, we want to build tools that enable people to be more productive or to kind of save time or whatever it is. But the key phrase here is that we want useful models. What we're doing at the moment with human feedback is we're asking people how useful they think the model is. And this is pretty close, but it's not quite the same thing. So I'd like to kind of go back to the same example again. If you say to the model, please tell me how to bake a cake. And it says, sure, here's a recipe for baking a cake. And it's got, you look at the recipe and it's got like eggs, it's got butter, it's got flour. You go, okay, like looks like a recipe. Great, thank you. It's all kind of nicely formatted. It was polite and helpful. It hasn't said anything racist. Great. And maybe that output gets a thumbs up. But until you actually take that recipe and you go to the kitchen and you make it and it turns into this kind of sloppy mess, you don't know that it was useful. It might have looked useful, but actually the difference between looking useful and that kind of sloppy mess of a cake is quite important. And I think what our work is kind of highlighting is that difference. And if we can find some way of capturing the actual utility of these models, I think that would be super powerful. I think I'm sure it would have other problems, but to an extent, it would kind of mitigate a lot of the issues we raise here. Another example might be if you maybe use your model to generate summaries about a topic. and then you use those summaries and you go and try to answer like an exam question or something. Until you go and you answer the exam question and you get the mark back, you don't know whether the summary was right. It could have looked plausible, but not necessarily correct. And if we can find a way to capture that kind of the mark of that test, if you will, and say, okay, this output was genuinely useful, and to kind of cover the error type that we identify in the paper, that summary has to be factual as well for you to pass that exam. So I think by trying to find objectives that actually capture the real usefulness of the models, not just the perceived usefulness, we'll start to incorporate a lot of the factors that preferences miss. And I suspect on the flip side, things like assertiveness kind of won't matter, because if it doesn't matter how assertive or not it is, if the cake recipe works, great. I don't really care what the tone was. That's almost secondary now, because I went and I tested it. So that's the second direction. I don't know how to get there. I think it's really interesting. I think it's also really hard, and probably quite expensive. But if we can find a way to do that at any kind of scale, then I think it would be super powerful.
Yeah, absolutely. And I think it just brings to question like what the future of natural language generation looks like, I suppose. Like, could we use instruction tuned model evaluators to address the limitations of traditional evaluation metrics, do you feel?
So this is a super interesting question. There's a whole bunch of work on approaches like this out there at the moment. I think the jury's out as to whether this is the future. So it has some distinct advantages. So on the one hand, it's super scalable. Getting a model to do the evaluation instead of people it's just cheaper. You can do it in a much higher throughput. It's very scalable. You can do it kind of automatically. So far, so good. It seems like it should be better as well. A model, you would expect that a model would be better at identifying factual errors. Models don't have attention spans. They don't have, they don't care about the kind of remuneration that they're getting for the task. So you would sort of expect them to be better at identifying factual errors and kind of checking for factual consistency. The flip side of this is these models were trained on human language. Often that language was kind of scraped from the web. It's probably pretty noisy, or I hate to kind of talk about quality of language, but there are some parts of the internet that I think we can confidently say are not good, that were used to train these models. So we've actually trained them to incorporate human biases almost on purpose, because they're trained to generate language that looks as close as possible to human language. And the way of doing that is to mirror as close as possible the biases of humans. So I think this is where it gets a little bit tricky. And this is before we even consider the fact that maybe because we've taken some kind of imperfect data and then modeled it, we've probably introduced some new biases. We haven't even considered what those might be. So I'm a little wary of using models as evaluators. I think it could be really promising. It could enable kind of scale and all these nice things. I think it needs a lot of validation. I think as we've shown in our work, that validation itself has to be done super carefully as well. It's not really sufficient to take a model, take some human data and go, look, we can predict the human data with some nice high accuracy. If the thing we're predicting is biased as well, then we're just kind of accurately predicting biases, if you see what I mean. And then we're kind of back to where we started. So if we can find a way to properly validate them, and even better, to try and mitigate and compensate for some of the downsides of human evaluation, then I think that's a super promising direction.
Yeah. And I think you maybe touched on this very briefly earlier in the conversation as well, but I think the participants who are doing these annotation tasks like could very well have an impact on the accuracy of the evaluation, I suppose. Were you targeting specific audiences, or was it more of a general population that you were presenting this study to?
So this is a super important point. It's in our work, there's two parts to this answer. So in our work, we kind of intentionally didn't engage with the fact that there is no single annotator. The kind of, there's no such thing as like the perfect human that we're trying to model. It doesn't exist. Not that humans are imperfect, but just humans are diverse, right? There are different cultures, there are different values. You can take that quite a long way, but I think even just at a superficial level, I like the example of UK versus US English. Neither of those is more right than the other. Which one you want is going to depend on the context that you're operating in. And engaging with that diversity and not only having a diverse group of participants, but modeling that diversity within your objective as well, I think is super important and super interesting. It's not something we dealt with in our work, partly just because we didn't need any more complexity. It was bad enough as it is. There are people out there working on this. There's a great project, I think it's called Prism, by Hannah Rose Kirk. If you're interested, go and look up that. They collected preference data from a whole bunch of different demographics and included those demographics as part of the data. So it kind of gives the potential to model, to model the objective in a much more intricate way. And like I said, engage with the diversity of annotators and make sure that these models don't just serve some kind of average person, but serve kind of more finer grained communities in a way that is actually beneficial to each of them, rather than kind of okay for everyone. Hopefully that makes sense. So the second part of this question is somewhat more mundane, I guess. So this is in terms of what we did on Prolific. Because we intentionally didn't really want to deal with this diversity in our work, the Prolific balanced participant recruitment setup was actually super useful for us. So it meant that essentially once we decided that we didn't want to model the diversity of opinions, we could at least have some guarantee that the participants we were getting weren't from one specific group more than any other. So I think if I remember rightly, the recruitment setup we used was actually pretty straightforward. We recruited L1 English speakers based in the US and UK, who had completed a minimum of 100 other experiments. So this is just to kind of make sure that anyone who's used an annotation platform before will know there are bots out there. There are people out there who kind of don't pay attention. They're not really interested in the task, and that's fair enough, but it does make doing the study a lot harder. So we wanted to make sure we were getting engaged participants. But other than that, we just kind of left it up to Prolific's recruitment algorithm. Yeah.
Nice. Yeah, and slightly shifting gears, I suppose, into the more prolific side. Like, I'm curious what your experience was like. Obviously you touched on some of the recruiting pieces, but overall experience with prolific. I'm curious to hear more about that.
Yeah, for sure. Um, so the to give a little bit of context, um, so we originally tried running this. We ran some pilots of this experiment with another annotation platform. I won't say who. Um, and the way we set it up was was essentially what I described earlier. We showed them outputs. We asked for annotations and scores. Um, but as part of that process, we had a little kind of text box underneath. Basically said, please give us any feedback. These boxes are super useful. Sometimes the interface has a bug, or maybe your instructions have a typo or something, and something's not clear. It's really good for participants to be able to feed that back and go, actually, we found this really difficult, or by the way, this button doesn't work, or whatever it is. So what was really interesting when we did this was we found a whole bunch of examples came back, and the annotators had rewritten the output and put it in that box, which was not something we'd asked them to do. At no point in the instructions did it say, please provide us with a rewritten version of the output. And what it kind of indicated was that the bulk of the annotation that happens on that particular platform is rewriting. And it seems like a participants had essentially seen the page come up, not read the instructions, rewritten the output, maybe with ChatGPT, maybe not, I don't know, and stuck it in the box. And we were kind of sat there going like, this is really interesting. Like people are doing a different study to the one we've asked them. They've just assumed that we're doing this kind of other study, not the one that we've said we're doing. Which is kind of funny, but also a bit of a problem, because we then really didn't trust the kind of quality of the ratings or the error annotations that we were getting. If people aren't reading the instructions, they're probably not doing what we've asked them to. I guess this comes back to this idea. If you're showing annotators 15 pages of instructions, are they really reading? Anyway, so we decided against using that particular platform. I spoke to a bunch of colleagues at my university, and Prolific has a pretty good reputation. People use it for kind of psychology studies, sociolinguistics studies, where the nature of what they're doing is much more about the humans than it is about the sort of annotation, if that makes sense. People have used it, people I know rather have used it in the past to kind of study humans as objects of study rather than to just get them to do work. What I think this means is that the participants on the platform do a much wider range of stuff. They're not primed to one kind of specific task. When they saw our study come up, they were like, oh, this is something kind of new and interesting and different. And I get the impressions from kind of some of the feedback in the boxes and some of the messages that people actually enjoyed doing the task, which is pretty cool. So yeah, using Prolific was pretty good. I would say but because Prolific's focus, as far as I understand it, is this kind of human studies rather than annotation work. The real strength of the platform is in recruiting participants, getting a diverse set of people, getting people who are engaged. The downside is that the kind of technology on the platform is it's set up to work with a pretty wide range of study types. And that's great if you're using a wide range of study types. But it does create a bit of a kind of activation hurdle to get over to set up an interface and kind of get things running. So there's a bit of work needed on our end to set up an interface and get kind of batches setting up, working how we wanted. I guess it's sort of the classic curse of freedom and flexibility. You know, we could set it up how we wanted, but then we had to set it up how we wanted. I guess there's not really any good way around that. So in the end, we used Potato, which is a open source annotation platform. We made a bunch of modifications to it. We kind of made the interface a little bit shinier. We sorted out a couple of little issues with dealing with participants who returned their study, just a kind of slightly fiddly edge case that needed covering. But then once that was all sorted, it was actually pretty straightforward. And yeah, I guess the main thing is the quality of participants. It's super hard to actually work out, to kind of work it out and put numbers on it. But it seemed from the data that we were getting that participants were genuinely engaging with the task and were in good faith trying to do it to the best of their ability. But firstly, that's super important whenever you're doing a kind of evaluation study, but definitely for the type of thing that we were doing here, where we're really interested not just in the output, but in the people themselves, having good estimates of what people are doing is super important. So I think it worked really, really well for that. I was just going to share, so I've since doing this study, I've used Prolific for another study as part of my PhD, and we ran a kind of pilot study with just a handful of examples, just to check that everything was working, before we ran the kind of full study. And I thought it was really interesting that the results of that pilot study pretty much perfectly predicted the results of the full-scale study, which is actually really nice. So this, like obviously you want to have a nice big pool of participants for a study, I mean, just to make sure that your results are statistically significant and make sure any kind of variation is accounted for. But yeah, I thought it was super nice that you could, if you didn't need that so much, you could run a pretty small scale study and probably trust the results to predict the results of the big study. That's actually pretty powerful. And I don't necessarily have any plans to use it right now, but knowing that capability is there, I think opens up the potential to run a bunch of studies that would otherwise be prohibitively expensive, because you'd have to, if you're searching for hypotheses or you're kind of testing out ideas, then you really don't want to have to run the full thing every time because it's super expensive. So if you can get away with kind of testing the water at a small scale and trust those results, that's pretty powerful.
Yeah, that is super interesting. Is that not something that you've found to be the case with other similar tools in the past, I suppose?
Honestly, no. I can't put any hard data on it. And like I say, it's like determining the quality of annotation is super difficult because, if we knew the right answer, we wouldn't be getting stuff annotated. So it's very hard to know what the kind of accuracy is, if you will. But yeah, I've definitely, I think anecdotally, other platforms, again, I'm not going to name names, are not known for being reliable or for recruiting I don't necessarily want to speculate about why it is. And like I said, kind of annotators are not the best paid. It's not the best paid job. So I feel really, I really don't want to throw annotators under the bus here. Like, thank you guys for what you do. But yeah, it is really important when you're running these studies to kind of trust the results that you're getting. And that's not always the case with other platforms. I guess, like, to an extent, so I can sort of put some numbers on it. So like I mentioned in this study, we included, so I call them distractor examples, where you show output that where you know what the right answer is, and you kind of it's output from a model that is based on a different input. So it really should be kind of downscored. It looks plausible, but if you actually dig into it even a little bit, it's pretty obvious that you've asked it to bake a cake and it's told you about some news story. Like it's just kind of unrelated, and it might be fluent and it might be convincing and it might be a good summary of that news story, but it's not what you asked for. So it's definitely bad. So if you then use those samples to work out kind of a rough proportion of how much of your annotation data is reliable and how much isn't, in the past on other platforms, I've had to reject quite large percentages of the data that I'm getting back because those attention checks have been failed. Which is not good. On Prolific, it was a pretty rare thing to have to reject something. So this bodes well, right? If you don't necessarily know what's going on with the tricky examples, but if you can at least guarantee that the easy cases are being done right, then it definitely gives you some faith that the study is working how it should be.
Yeah, that's super interesting. I guess, conscious of your time, Tom, I'll maybe boil everything. Like, the big question that I have is like, what advice would you give for researchers looking to have more reliable evaluation frameworks? Like, what you're the one to go to, what advice would you give, I suppose?
Oh, yeah, that's the $1 billion question. I think it really boils down to essentially two very short things, which encompass they're kind of almost banal in how, essentially be careful, design your experiment super carefully, check the quality of your data, be tight with your instructions, kind of pilot it, get your friends, colleagues to look at it and go, it's honestly amazing how ambiguous this stuff can be and how easy it is to write instructions that have an alternative meaning that isn't what you meant. And the more people you can get to look at it and go, are you sure? The more likely you are to kind of cover any of those edge cases. So that's one thing, is kind of be careful and pay attention to the details. The second thing I think is engage with the fact that these are people. And despite what I've spent the past hour saying, like, annotators, they're not bad people. They're not trying to mess up your experiment. It's hard. And evaluating factuality is genuinely really difficult. Having done some of these myself, there's some really weird cases where you can't find the evidence to back something up, but maybe it's true, or vice versa. You find some evidence, and interpreting whether that evidence supports what the model has said is really quite subtle. So engage with the fact that these are people. Engage with the fact that these are diverse people as well, and that what might look like annotation noise is actually just you've asked a diverse group of people and you've got a diverse set of responses. And I guess on a kind of similar note is this idea of asking people what they think isn't necessarily the same as determining whether something is true. And that's not because the people are doing it wrong. It's because it's a different question. And engaging with that, respecting it, and it kind of working out exactly what it is you do want to achieve, and then measuring that rather than trying to measure some proxy and then complaining when it's gone badly. I think these are the ways forward.
Yeah, I think that sums it up really well. I guess any last thoughts from you, Tom? Any teasers on future work? Anything that you've got coming up next? I'm curious because this is super interesting to me, and I'm sure that the next research that you'll be doing is going to be even more captivating.
So I no current plans at the moment, but there are definitely two directions that I'm interested in. I would love to see people take these ideas forward. If anyone watching would like to take them forward and would like to collaborate, reach out to me. Find me on Twitter, email, whatever. Just get in touch. So the first is that what we did in this work was we looked at the annotation stage. So we said we're annotating for human preferences. We identify some biases in them. But the kind of current LLM stack looks something like we have human feedback data, then we train a reward model to try and predict that feedback data. Then we train another LLM to maximize the rewards from the reward model, which was trained on the human feedback data. And then potentially it's looking like we're going to use that LLM to evaluate other LLMs. So we're now using an LLM that was trained on a reward model that was trained on human feedback data. And I would be astonished if the errors are diminishing as this stack gets deeper. They're just 100% getting bigger. So I would love to see a study where we dig into that and say, okay, we know if you like, we've established the baseline. We know what the biases are in the data. Okay, now let's look at the reward model trained on that data. Have the biases got worse? How have they got worse? Have we introduced new ones? Have we kind of skewed things differently? That's kind of one level. Then we look at the language model trained on the reward model. This is sort of level 2. Now what's happened to the biases? Are there new ones? Have they got bigger? Have they got smaller? And to do that in a really targeted way where the only thing that changes is whether it was trained on the rewards or not, I think would be super interesting. So the second study, given that this is based off my experience with this mystery other provider. So given that one way of framing what happened there is that platform has, by accident, primed their participants to expect a certain type of task. And that priming has kind of persisted between experiments. And I think this is super interesting. So what I'm wondering, and setting this up as an experiment would be super difficult, but I wonder whether as things like ChatGPT or other competitors have got more and more popular, people are kind of seeing this output, they're liking it. I wonder whether we, as a population, are priming ourselves to prefer language model outputs over actual human data. Because if we are by accident, I mean, firstly, that's wild. But secondly, that causes a real practical issue, because if we, let's say imagine we have version 4 of a model that's kind of out there and being used, and everyone's kind of using it and consuming it, and it's generally sort of well liked. Imagine then version 5 comes out, and according to things like factuality or whatever, it seems better. But because everyone's used to version 4, are they going to actually prefer version 5, or are they going to go, well, I actually quite liked version 4 because I'm used to it now? So I think this is a very kind of subtle effect, and I suspect that we've probably missed the boat on this already, because these models are out there, people are using them. Finding people who have not used them yet and then showing them outputs to kind of test this priming effect would be really difficult. But trying to dig into that a little more, I think, would be super interesting.
Oh, yeah. Well, as Tom mentioned, anyone looking to collaborate, get in touch. We can certainly, post your LinkedIn along with this webinar if that would be helpful.
Yeah, for
but
sure.
Anyway, thank you so much for joining me. It's been great having this conversation. For anyone interested in reading Tom's paper as well, we'll include a link to that along with this webinar. So please go check that out. And yeah, I guess thanks again, and bye everyone.
Great. Thanks for having me. See ya.